A simply supported beam of span 6 meters is subjected to loading as shown in figure. Determine the reactions at A and B. These are two supports, simple supports A and B, and this is one loading, point loading of 5 kN, and this is point loading of 5 kN, and this is 3 kN meter per meter uniformly distributed rectangular load. We have to find reactions at A and B. We have to find out reaction at A and reaction at B. Now, reactions at A and B will be VA and VB. Because these are simple supports, there will be only one reaction at A and one reaction at B. Now, marking vertical forces as red. Now, these are two vertical reactions, and these are 2 point loads, and this is converted load of point load from the rectangular uniformly distributed load of 3 kN per meter. 3 kN per meter. This 3 kN is over a span of 3 meters, so it is converted to single point load of 9 kilonewton, like as 3 into 3, 9, and it will act at the center of the rectangle. So it will act at the center of rectangle. So it will be 9 kilonewton, and it will act 1.5 meters from this starting end of the loading. So this 9 kilonewton will be acting at 1.5 meters from starting point of rectangular loading. So resolving forces vertically and equating to 0, that is summation Fi equal to 0. Vertical forces Va and Vb summation will be equal to summation of downward forces 5 plus 9 plus 5, Va plus Vb, Va plus Vb equal to 5 plus 9 plus 5 equal to 19. Say it as equation 1. Now, taking moment of forces about point A. Now, taking moment of forces about point A and equating to 0. Here, VA is passing through point A, so it will have 0 perpendicular distance about point A. So, VA will have 0 moment about point A. And now, considering this 5 kN force, it will have line of action of force like this, and it will travel or pass through line of action of force like this, and it will have perpendicular distance of 1.5 meters from point A, and it will rotate about point A like this, 5 into 1.5 meters. Now, this 9 kilonewton force will have a line of action of force like this, and it will travel or pass through line of action of force like this, and it will have perpendicular distance about point A, this 1.5 and this 1.5, 3 meters from point A, and it will rotate about point A like this. It will have magnitude of 9 into 3. 9 into 3. Now, this 5 kilonewton force will have line of action of force like this. It will travel or pass through line of action of force like this, and it will have perpendicular distance of this 1.5 plus 3, 4.5 meters from point A, and it will rotate about point A like this clockwise, and this VB force will have line of action of force like this, and it will travel along line of action of force like this, and it will have perpendicular distance about point A, 1.5, 3 and 1.5, 6 meters from point A, and it will rotate about point A like this, and it will have magnitude of VB into 6 minus VB into 6, because it is rotating about point A anticlockwise. So VB into 6. So what we have done is we have resolved forces vertically and equated to 0. We got equation in VA and VB equal to 19 kilonewton, and we have taken moment of forces about point A, that is 5 into 1.5, 9 into this 4.5, 3 meters, 9 into 3 meters, and this 5 into 1.5 plus 3, 5 into 4.5, and VB into 6. So we get equation in VB, and calculating for VB, substituting VB value in this equation, we get VA value. Finally, writing reactions at A and B. Reactions at A will be 9.5, 9.5, and reaction at B will be 9.5 kilonewtons.